Hi everyone, just want to welcome you back from lunch. We have some great talks lined up for this afternoon, including my own talk. But before we get to that, I'd like to introduce TJ and Dave from Trupanion. We give you a very, very interesting look at the market of pet insurance, machine learning. So let's give them a round of applause.
All right, thanks everybody. So to start off, I'll just talk a little bit about our industry and our company, and Dave's going to talk about some case studies that we have. Wrong button. Oh, come on. Oh, next. Here we go. All right, so Trupanion, we're based in Seattle. It's a, let's call it a medium-sized company. We've about 140 million in revenue, about 450 employees, and been around since 2000 and started in Vancouver. And we operate in sort of the pet insurance industry. So, sorry, wrong button again. Can you pull it back up? All right. So the overall industry, the idea is that it pays for your vet bills if your pet gets sick or injured. It's about a $500 million industry. It's something that's pretty common in some European countries, but only about 1% of pets in the US and Canada are insured. So we look at that as a really big opportunity. So growing in the low double digits, but a couple of companies, ours included, are sort of driving that growth. And I mentioned on here that it's interesting from sort of the insurance world because it has an interesting blend between being property and casualty from a regulatory standpoint, but sort of health from a risk categorization. So you might be wondering a little bit about why this industry even exists, and I think this is the best way to describe it. So veterinarians were surveyed and said, okay, to what extent has cost been a factor in limiting treatment on pets? And so they say 25% of the time, cost is not a factor at all. 30% of the time, they say that cost was a factor, but they did it anyway, which mostly just means that the person complained about it, which is pretty typical. But then we get into a big chunk of time, 28% of the time, they say that cost actually limited treatment, and then another 17, the client declined treatment because of that. So pets are getting suboptimal care because clients can't pay for it. It's bad for the client, it's bad for the vet. And so that's where the insurance sort of steps in. And Trupanion's approach to the market has been a little different from others, where we really designed the product we wanted from a coverage standpoint, but then we have to be really precise around our pricing for that. So in a lot of other cases, you'll have just sort of one blanket price and then a limited coverage for various, we have the exact same policy for a cat and a St. Bernard. Those end up being very, very different risks. So we need to have a really thorough study of our data to be able to understand what that pricing should be. And so our sort of data science and analytics department really grew out of our actuarial team. Owen was saying earlier, like, don't laugh, I almost became an actuary. So I did become an actuary, but now I'm focused on just a wider range of data science and things like that. And so our analytics team, like I said, we started as sort of the actuarial team doing the pricing, but then as a small growing company, we started working on a bunch of different elements of the company. So we're using our analytical skills to improve the acquisition of customers, the retention of customers, fraud detection, pretty much anything around the company where we need that. So our team ended up being called the Truth Department because basically all data sort of flows through our team. And I was thinking before about all the discussion about data scientists and the three sort of skills that data scientists need that get brought into everyone's talk. And it's really hard to have all three of those in a lot of specificity or a high level of expertise. And so we've built up a really strong team that is able, as all of us combined, from our backgrounds of a variety of disciplines, are able to have a strong team. And so, like I said, we sort of span across the entire company and just bring together our sort of wide range of backgrounds. There's a total of 9. And so in the past, most of us have been actuaries, and then about 2 years ago, we wanted to expand that toolbox beyond just the actuarial skills And so that's when we brought on Dave to bring on some more machine learning and a broader skill set. And these are some of the rest of our team members that show up at the office every day. So that's just something that we always like to share.
Okay, hello everybody. Thank you very much for coming to our talk. I am going to go over a few of our data science use cases, and they are very specific to our company. I mean, we're an insurance company. Shoot, okay, here we go. But it should be fairly general to where it could be interesting to you too. A few of the techniques I'll describe as not, insurance company specific. Okay, so I'll describe building and using two models for you guys today. First is customer churn. So we kind of resemble a subscription-based company in that we collect a premium from all of our customers every month, and in return, we provide the service of paying for veterinary bills. Okay? And as such, all of our customers are faced with the decision every month: do I want to continue paying for this service, or do I want to cancel? So we're interested in identifying those most likely to cancel. So that's a customer churn model. And we are an insurance company, so we do have the cost of paying out claims. How much do we expect to pay any given pet in any given month for the duration of their policy? So two different models. One is predicting a binary value, right? Are they staying with us or are they leaving? It's a 0 or a 1. Second, when we talk about claims projection, it now becomes a slightly more complex problem of it's predicting a dollar amount. How many dollars do we expect to pay in a given month? Okay. I'm aiming the clicker in the wrong way. Our problem starts the same way as all data science problems: getting the data. Okay. We have an awesome data warehouse team that collects everything we need to know and stores it in a very predictable and in a way that makes a lot of sense. However, this data is not ready to build a model. It's not ready for analysis in its raw form. Okay. To simplify down our data, I'll talk about three general sources. We have the enrollment table, which contains all of the account details of all of our pets. This includes breed, age, zip code, what hospitals they go to. Okay, so this is a 1 row per pet. Okay. Next, we'll talk about our claim table, and what this contains is it's no longer a 1 entry per pet. It's now counting all of their doctor's visits and all of the medical bills that they incur. So let's say they go to the vet once a year, just for 3 years. Then we'll have 3 entries in that table. And finally, we'll talk about a change history table. And what this contains is just rate increases, any deductible they decide to raise or lower their deductible. This will be contained in the change table. Okay, so a very obvious first step is, since we're predicting, let's say, customer churn, we want our data on the customer level. So what can we do to combine these sources? Well, a very simple way of doing things would be to maybe sum all of the claims or sum all the deductible changes onto the pet level. So combine everything onto our enroll table, okay? And then we'll have a classifier that predicts, well, given all of these features, what is the probability of a pet canceling or a pet staying with us, okay? But I propose we can do better. So instead of having it on the pet level, we collapse it down to pet per unit time. And what this means is, instead of let's say, looking at a pet that's been with us for 5 years and then cancels, we want to look at it time-wise, time series-wise. So that pet may have, or the owner of the pet is who we're trying to model. Say the owner of the pet has been really happy with us the first 4 years, and then something happens on the 5th year that causes him to cancel. That won't be captured unless we kind of loop through time and take snapshots of their experience. Okay, so I say that pet isn't actually a cancel. It's more like, what did I say, 5 years? I guess it would be 59 months of good experience and 1 month of bad experience. So we model it that way. And just to give you an idea of the scale, not super important, but we have about 500 pets that have ever been enrolled with us. And once we introduce this time looping effect, we generate about 7 million samples. So in general, a bigger training sample gives you better model. Okay? And some things, some things stay the same throughout this process, like their breed, their medical history, whether it's a dog or a cat. Some things will never change. However, things like age of pet, of course, pets get older and that changes their experience. How many times they call us, how many times we pay them a claim, how many times we give them a rate increase. These things are all changing with time. And here we can get very creative with our feature engineering. We can use our domain expertise. For example, I know that our claims department is barely staffed on Sunday. It's like a fraction of how many people are usually staffed. So since we're modeling a claims payout on a monthly basis, what if the month starts on a Sunday? So now we have a higher proportion of Sundays compared to full work days, and that'll affect how much we pay out for total in that given month. Okay. And also, before we even start modeling, we need to think about what our end goal is. So in the example of predicting customer churn, once we have that model, what are we going to do with it? Well, the obvious answer, or the first thing that pops in my mind is we can target those most likely to cancel and reach out to them, apply like an extra layer of retention efforts. And those retention efforts only work if the reason why they're canceling is controllable, if it's their own choice. I had mentioned that we have access to all of their veterinary records. We could very well go into those records and pick out pets that have had like terminal claims, like pets who have gotten cancer, and we're fairly certain these pets will cancel in the next. It's very sad, I know, but those pets will likely cancel in the next 2 months. However, we don't want the model to pick those pets out because there's nothing we can do about it. So in the example of customer churn, we really want to filter those out. Don't even learn about them. However, if we're trying to predict how much we pay out in a given month, then by all means, we should be using that condition level data. Okay. Okay, so we use DataRobot. How we prepare this model and all the feature engineering I do in R, okay, and I just generate a CSV and simply drag and drop it into DataRobot's web interface, and they'll do all the model building for us, which is awesome. One thing I did want to mention is that we do a little bit differently is when we validate our model. So let's say our model is fully built. Generally, you want to segment out a holdout set to see if your model is overfit. We don't do that, and here's why. Let's say I want to predict who cancels in December. I would rather use model, let's say, January through June to build the model, then hold out July, August, September, and then test the model in those months. The reason being is our company is growing at a pretty fast rate, and our mix of pets and experiences aren't necessarily at steady state, especially since this is, again, domain knowledge. Our IT department's pushing software to vet hospitals at a really high rate, and this new software lets us process and adjudicate claims at just several times faster than we used to. So we expect an increase in costs. So that means when we are evaluating our model, we can't really use what's happened in the past as an indicator to predict the future, just because it's constantly changing. And if we use more recent months as a holdout, test on those recent months, we can kind of get a feel of, is my model, like, are things changing too fast for us to accurately predict? Okay, and here's what the DataRobot interface looks like. It's each line here represents a different type of prediction algorithm. Let's say the text is a little bit too small for you guys to read, but let's say one of them may be a random forest, and another one may be a SVM or something like that. X-axis would be how much data they're exposed to. So as we go to the right, the models are training on bigger and bigger samples, and the y-axis would be increasing error. So the models with lower y values would be the more accurate models. And it's super cool that they do it this way, because the same models that would do very well predicting customer churn might not do so well predicting claims amount paid. So it's kind of built in. The best model for the particular application will be selected. All right. As TJ alluded to earlier, risk is very different from pet to pet. We don't expect to pay out the same amount for, let's say, a small kitten or compared to a huge dog like a Saint Bernard, right? So we have to price those two risks differently. And here are some example results. Numbers aren't super important, but the columns in black are our features, a small sample of our features. The numbers in red are what was actually paid out in a given month, and the numbers in blue is what the model predicted. So you'll notice that so we have breed discretized. We can't have 1,000 different breeds of text and just plug it into a model. That's pointless. Instead, we have this system of just assigning a risk factor to a breed. So let's say a kitten would be a 0.5 and Saint Bernard would be a 2, for example. Okay, you'll see that breed really isn't that predictive of a variable. What's really predictive is of whether or not, or how much money we're going to pay them next month in claims is how much we've already paid them in claims. That's really the dominating factor here. The sick pets, the known sick pets, are the ones that we expect to lose out the most money on. All right. Values here aren't an exact match, right? We can't predict who gets hit by a car or whatever. We can't really get to that dollar amount, but you'll see that the model is really good at picking out which pets incur big claims. And this is especially true when knowing that our company really, only 1 out of 10 pets in any given month will even file a claim. Will even have a non-zero value in the red column. Okay, and here's the other end of the spectrum. As you can see, pets with these characteristics, like they're very young and healthy, they have very high deductibles, they're almost certainly not going to incur a claim. Okay, recall that we are talking about two models, okay? One, I just went over the claims model, but the first one we're talking about is customer churn. Again, let's think about what we're going to do with this data. We really want to just save some policies. We want to prevent these people from canceling. And really, it's a matter of spending energy. Someone has to either design some marketing piece to send out to them, or someone on the phones has to reach out and talk to these customers. So what do we really care about? We really care about a very small sample, a very targeted, very tight range of pets likely to cancel. And as you can see, if we narrow the selection enough, let's say if we take, out of the 200,000 pets that we have, let's take the top 100, then actually about 50 to 60% of them will actually cancel in that month. So we're getting, I guess I should have told you, our normal cancel rate in a given month is only about 1.4%. So going from 1.4%, just selecting randomly, down to 50 to 60, I think it's a pretty impressive result. At that point, we can do a targeted campaign. Okay, I'm gonna give it back to TJ.
Thanks. So one of the main things that we wanted to convey here, and I think it's been something that we've been pretty successful in at Trupanion, is connecting our analytics to the rest of the company. And so we had a couple of takeaways from our experience in introducing these models to the various operational teams. And so the key things that we came away with was, for one thing, start with a problem that is simple. So the cancellation model is a great one. So people understand the idea of somebody's going to cancel or they're not, and that's something that's predictable. It's something that's familiar. We have a daily report that goes out every day talking about the number of pets that canceled. So it's definitely something that is on people's minds. So it's really helpful to start introducing the company to this concept with a problem that is something that's very familiar to them, and then of course something that's very important. And so everybody knows that we as a subscription business live and die by our LVP and our retention, lifetime value of a pet, customer lifetime contribution, that sort of thing. So we live with that, and so it's definitely something that people understand to be very important within the company. One thing that I think is not necessarily intuitive to a lot of data scientists is we found it very helpful to actually walk these operational teams through the model. So even if if the CEO is not necessarily associated with this level of expertise, it really did help us to go through, here's the data set we're looking at, here's the stuff that we did to clean the data, and here's what we did to actually execute this model. It really gives them confidence in your skills as a data scientist and the results, so when they can really see that effort. Next thing is appeal to their intuition. So Dave showed some of the examples. So who are the pets that are really likely to cancel? Who's the ones that aren't? Who's the ones who are likely to file claims? And that's where sort of that experience within the industry becomes really important, because then you can explain why these results make sense. And then the ironic thing is that if you appeal to their intuition too much, then they're thinking, why did you just do this to tell me something I already know anyway? But so I think it's important to not only can you show them what's going on from a general standpoint, but also we've now quantified the things that you had in your head in terms of your intuition about what's going on. So walking through and talking about the specific drivers of cancellations and things like that is really, really helpful. And then showing the proof metrics, showing the curves, demonstrating that, all right, when these certain cohorts of policyholders were predicted to do these behaviors, and then we were able to show that they actually did, as Dave talked about, going through the exercise of having the predict 1 month and then see what the actuals are. It's really important to be able to share that with your business units in order to sort of convince them of the power here. And then the last piece that I wanted to mention is having a sense of the action steps. So as Dave mentioned, the steps when it comes to a cancellation model is, all right, we might go and proactively call out to these policyholders. Well, if you're providing that action step, then it gives more context to the end user, whether or not they're going to follow through with that or not. It gives them more confidence that you understand what their operational world is like, and also gives them more context for the model that you've built. So with that, let's see if there are any questions. And if not, that'll be it. Thanks.